Let's now talk about some formulas. The first formula is called the addition rule, and it's a formula for finding OR probabilities. So probability of A or B is equal to probability of A plus probability of B. So that's where the name addition comes from, minus the probability of A and B. Now notice that we already know how to find OR probabilities without using a formula at all. In the last lecture, I asked for something like probability of San Francisco or train. And the way we found it in the last lecture was we first started by taking all the San Francisco numbers, which is 5, 9, 15, and then we added on the train numbers, but keeping in mind not to count anything twice. So we only added on the 15 and the 6 because the 9 we already counted when we did the San Francisco numbers. Right, that's how we found the OR probabilities in the last lecture. So what this formula is saying is that if we wanted probability of San Francisco or train, it says take all the San Francisco numbers plus all the train numbers, and notice that I counted the 9 twice, and now subtract off the probability of San Francisco and train. So San Francisco and train, remember the word and means at the same time. San Francisco and train at the same time refers to the 9. So all this minus probability of A and B part is doing is it's subtracting off the thing that we counted twice. Okay, and that's where this formula comes from. The next one is called the multiplication rule, which we also already talked about in the last lecture, and we used it to find the probability of picking 2 people, right? We said picking 1 person and then picking a second person. And the way we did that was we ended up with 2 fractions that are multiplied together. So this first one is exactly the same multiplication rule that we talked about in the last lecture. The second one, all I did was I swapped the B and A. Okay, so I replaced A with B and B with A, and you get the second formula. And the reason why I need the second one is because and the order doesn't matter. Okay, so A and B is the same thing as B and A. So on the left side, these two are actually the same. But on the right side, we have conditional probability. So for conditional probability, the one that has the line or the word given, the order does matter. Right? So P of B given A is different than P of A given B. So depending on the problem, sometimes you need the first one, sometimes you need the second one. Last set of formulas we'll need is called the rule of complements. So if E represents it rains today, the complement, remember, just add on the word not. So the complement would mean it does not rain today. And all these 2 formulas are saying is that if you know one of them, do 1 minus and you'll get the other one. That's all these 2 are saying. When would we use those formulas? Well, we would use those formulas when we're not given a table and we're just given the probabilities like we are here. So suppose that probability of G is 0.45, probability of H is 0.15, probability of G given H is 0.70. Find the following quantities. So I'll need the formulas on the previous page. And really, I just need the first 3. Now, these formulas are written with A's and B's. My question here is asking about G and H's. So what I'm going to do is I'm going to rewrite these formulas, these 3 formulas, with G's and H's. So I'm going to replace the A with G and the B with H. Okay, and the 3 formulas I'll get, I'm going to write up here. So the first one is the addition one, so that's probability of G or H is equal to probability of G plus probability of H minus the probability of G and H. And all I did was I replaced the A with G, the B with H. Okay, that's the first one, which is the addition rule. The second one is going to be the multiplication rule, the first one. So replace the A with G and the B with H. So that's going to give me probability of G and H equals the probability of G times the probability of H given G. So be careful, make sure you have everything in the right order. So the way I remember it is if I want G and H, then it's going to be G, H, G. So it's going to alternate. G, H, G. And then the third formula that I'll need is going to be the second version of the multiplication rule, where the letters are switched. So the third one I'm going to use is, I'll write that down here. So I'll just switch the G and H. So that's H and G equals, then it's going to go H, G, H. So alternate. H, G given H. Okay, and that's all we need for the rest of this question here. Part A is asking for a probability of G and H. Okay, question is, which formula do you use? First, second, or third? So which ones have G and H in them? The first one does, right? I see a G and H there. The second one does also. And the third one also does, because remember I said for ands, the order doesn't matter. So H and G is the same thing as G and H. So all three formulas have G and H in them. Okay, so that doesn't help us because we're trying to figure out which one to use. Well, can we use the first one? So the first one, probability of G and H, is here. In order to use the first one, we would need to know everything else in the formula. Okay, so G and H, do I know probability of G? Yes, I know it's 0.45. Do I know probability of H? Yes, I know it's 0.15. Do I know probability of G or H? No, right? So I'm not giving that. I'm giving just regular G, regular H, and then G given H. So formula 1 is no good because I don't know everything else that I need, right? I know probability of G, I know probability of H, but I don't know this G or H. It's not given to me in the problem. So 1 is no good. Can I use 2? So probability G and H, that's right here. In order to use this formula, I would need to know the other two things, or everything else in the formula. Do I know probability of G? Yes, 0.45. Do I know probability of H given G? No, I know G given H, but that's not the same as H given G. So I don't know this H given G, which means I can't use 2. So the only one I can use is this last one. Do I know probability of H? Yes. Do I know probability G given H? Yes also, which means the third one's going to be useful. So I'm going to use the third one. Let me recopy it. Left side, probably H and G. That's actually what I'm looking for. So let me just call that the whole thing X equals probability of H. Do I know that? Yes, it's 0.15. So this entire thing is 0.15. There's a multiplication there. G given H. What is probability G given H? G given H is 0.70, so this entire thing is 0.70. And then our job is to get the X by itself. The X is already by itself on the left side, which means all I need to do is just do that. So 0.15 times 0.70. $0.105. Okay, so what I just found was probability G and H is 0.105. Let me write that over here. Part B, probability of G or H. So look for a formula that has G or H in it. There's only one that has the or in it. That's the first one. So we have no choice but to use the first one. So let me recopy it. So it's going to be G or H equals probability of G plus probability of H minus the probability of G in H. Okay, go through, fill stuff in. Probability G or H, that's actually exactly what I'm looking for. Let me call that X. I have an equals right here. P of G, probability of G. Do I know that? I do. I know it's 0.45. So that entire thing is 0.45 plus probability of H. What's the probability of H? 0.15, so that entire thing is 0.15 minus probability of G in H. What's the probability of G in H? Well, we just found it, and we said it was 0.105. So that goes there. Get the x by itself. The x is already by itself on the left side, so all we need to do is do the stuff on the right side. So that's just going to be 0.45 plus 0.15 minus 0.105. 0.495. Okay, so what we just found was G or H. And that was 0.495. Part C, probability of H given G. Okay, so which formula has H given G? So this is conditional probability. The order does matter for these probabilities. So which one has H given G in that order? H given G. So 3 has G given H. That's not it. 2 has H given G. So I think 2 is the only one that has H given G in that order, H given G. So we have to use 2. So let me recopy 2. So G and H equals probability of G times H given G, times probability H given G. Okay, so let's go through, fill stuff in. G and H. Do I know G and H? I do. So G and H is 0.105. So this entire thing is 0.105. There's an equals probability of G. Do I know that? Probability of G, I do know, is 0.45. And then there's a times there. Probability H given G. That's actually what I'm looking for, right? Probability of H given G. So this entire thing, I'm going to replace with an X. And the job, your job, or our job, is to get the X by itself. So right now the X is not by itself, right? Because it's multiplying the 0.45. So I need to get rid of the 0.45. How do you get rid of the 0.45? Right now, it's multiplying the X. So to get rid of the 0.45, we're going to undo the multiplication. To undo a multiplication, we're going to divide. So we're going to divide both sides by 0.45. All right, so left side, we're just going to do that math. 0.45 divided, or 0.105 divided by 0.45. 0.105 divided by 0.45. Round to 3 decimal places, that's 0.233. Right side, 0.45 multiplying and then dividing by 0.45, that will cancel each other out and you'll have just X. And now X is by itself, so we're done. So what we just found was probability of H given G. And we said that was 0.233. Part D, are G and H independent? Explain. So anytime I'm asking about independent or mutually exclusive, and I said explain, I want you to check one of those equations on the front page. So which one are we checking? We're talking about independent. Which one's independent? Let's this one. So probability of A equals probability A given B. And because we're talking about G's and H's here, let me replace the A with G. And the B with H. So the one we're checking is this one. Probability of G equals probability of G given H. And all we need to do is figure out the left side, figure out the right side, and see if they're equal or not. So left side and right side, we should already know based on everything we've done already. Probability of G, we know, is 0.45. That's given to us in the problem. Right side, G given H, do we know that somewhere? It's not that, right? That's G given H, that's in the wrong order. So where do we know G given H? It's not that, that's an or. It's not that, that's an and. Is it in the original problem? Yes, G given H, 0.70. G given H, 0.70. Question is, are those two things equal? No, they're not. So it's not equal. To answer the question, they're not independent. Part E, are G and H mutually exclusive? So once again, you're going to check one of those equations on the front page. Mutually exclusive would be this equation, P of A and B equals 0. And then we're talking about G and H in this question, so let me replace that with the correct letters. So that's G and H. Check left, check right. Left side, P of G and H. Okay, that should be something we've already done. So where's G and H? There it is, G and H, 0.105. Okay, that's the left side. The right side, there's nothing to do. It's just 0. Are those equal? No, they're not. So if it's not equal, then to answer the question, it's not mutually exclusive. Example 3. So we're not given a table. We're just given the probabilities. Probability of C is 0.8. Probability of D is 0.6. Probability of C or D is 0.92. So we're going to have to use those formulas. So let me start by rewriting those 3 formulas, the addition rule and the 2 multiplication rules, using the letters that are in this problem. So with C's and D's. So I'm going to replace the A and B with a C and a D. So 3 formulas we'll get is, the first one is the addition rule one. So that one we'll say probability of C or D is equal to probability of C plus probability of D minus the and, C and D. Okay, the second one will be the multiplication rule. So that's probability of C and D is equal to the probability of C times the probability of, make sure you get the right order here. The way I remember it is that it's going to alternate. So C, D given C. Okay, so C, D, C. So it alternates. And then the third one I need is the multiplication rule again, but with the C's and D's swapped. So in the other order. That's going to say D and C is equal to the probability of, it's going to be D, and then make sure you get the correct order here. It's going to alternate, so probability of D times the probability of C given D. Okay. So make sure you have the second and third formulas, make sure you have the correct orders on the right side. Part A. Find probability of C and D. Okay, so look for the equation that has C and D's in them. I see it right there in the first one. I see it in the second one. And I also see it in the third one because for ands, the order doesn't matter. So D and C is the same thing as C and D. So I see them in all three equations. Which equation do we use? And remember, to use an equation, you have to know everything else. Okay? So equation 1, the C and D is right here. In order to use that first equation, I need to know these other things. Do I know everything else? Do I know probability of D? Yes, 0.6. Do I know probability of C? Yes, it's 0.8. Do I know C or D? Yes, it's 0.92. Okay, so 1 is going to be good. Equation 1 is going to be good because I know everything else. So let's use equation 1. And then you'll see that for the other ones, you can't use them because there's something that you don't know in each of those formulas. So the only one that's going to work in this situation is going to be equation 1. So let me recopy that. C or D equals probability of C plus probability of D minus probability of C and D. Okay, go through and plug in numbers. The left side here, C or D. Do I know C or D? I do. It's 0.92. So that entire thing is 0.92. I have an equals right here. Probability of C, do I know that? Yes, it's 0.8. Plus probability of D, do I know that? Yes, it's 0.6. Minus probability of C and D, do I know that? No, that's actually what I'm trying to find. So let me call that X. And now our job is to get that X by itself. So the X currently has this 0.8 and this 0.6, so I need to actually get rid of those. But first, let me clean up both sides first. Left side is just the 0.92, so I don't need to clean that up. Right side, I can clean it up by just combining those, 0.8 plus 0.6. What's 0.8 plus 0.6? 1.4. And now I want to get rid of this 1.4. So right now, it's being added to this negative x. So to undo an addition, you're going to subtract both sides. So subtract. Left side, 0.92 minus 1.4. Negative 0.48. Equals, on the right side, the 1.4 minus 1.4, those will cancel out, and then you're left with minus x. So negative 0.48 is negative x. I don't want negative x, I want regular x. So if negative 0.48 is negative x, then regular x is going to be 0.48. Or you can just divide both sides by negative 1. That will also get rid of the negative. Okay, x is 0.48. So we just found P of C and D is 0.48. Very good. Part B, probability of C given D. Okay, so conditional probability, the one with the line, the one with the word given, the order does matter. So look for C given D in our formulas in that specific order, C given D. Formula 1 doesn't have C given D. Formula 2 has D given C. That's the wrong order. Formula 3 does have C given D in that exact order. So we're going to use formula 3. So let me recopy it. Probability of D and C equals probability of D times probability of C given D. Okay, go through, plug in numbers. Left side, probability D and C. D and C, remember, and the order doesn't matter, so D and C is actually the same thing as C and D, which we know is 0.48. equals probability of D. D we know from the original question, it's 0.6, times probability of C given D. That's actually what I'm looking for, so that's just going to be regular x. Get the x by itself. Right now, there's a 0.6 multiplying the x. To get rid of a multiplication, you divide. You do the opposite. So divide both sides by 0.6. And then left side, 0.48 divided by 0.6. 0.8. On the right side, the 0.6 divided by 0.6, that will cancel each other out, and you just get x. So that's our answer. Let me write down what we just found, though. We just found this, probability of C given D. And we found that that was 0.8. C, probability D given C. So conditional probability order matters. So look for D given C in that exact order. And that will appear right there in equation 2. So we're going to use equation 2. I'm going to recopy it. Probability of C and D equals probability of C times probability of D given C. Go through, plug in numbers. Probability of C and D, where is that? Right there, 0.48. Equals probability of C, right there, 0.8. Times probability of D given C, that's actually what I'm looking for. So that's going to be my x. Get the x by itself. Right now, there's only a 0.8 multiplying it, so get rid of the 0.8. To get rid of the 0.8, which is currently multiplying, you do the opposite, which is divide both sides by 0.8. Okay, so I'm going to spill over onto the next part here. Left side, 0.48 divided by 0.8, 0.6. Equals on the right side, multiplying by 0.8 and then dividing by 0.8. That's going to cancel each other out, and you'll just get regular x. And so what did we just find? We just found this, probability of D given C. So probability of D given C is, we said, 0.6. Part D, are C and D mutually exclusive? Okay, that means we're going to check one of the equations on the front page. So mutually exclusive is which equation? This one. So probability of A and B is equal to 0. And then for this question, since we're talking about C's and D's, let me replace the A with C and the B with D. Okay, check left, check right, and check whether or not they're equal. Left side, C and D. C and D, we found already, right there, it's 0.48. Right side, there's nothing to do. Right side just 0, so right side is 0. Are they equal? They're not. So they're not equal, which means this is going to be not. This one's asking about mutually exclusive, so this one will be not mutually exclusive. E, are C and D independent? So this one we're going to check This one should actually say where we're checking that. Okay, anytime I'm asking about independent or mutually exclusive, I want you to check one of the equations up on the front page. We're talking about independent, so we're checking this one. Probability of A equals probability A given B. And then because we're talking about C's and D's in this question, I'm going to replace the A with a C and the B with a D. And then we'll check the left, check the right. Left is probability of C. Okay, that should be something either in the original question or something we found already. Probability of C, 0.8. Right side, probability of C given D. Where have we seen probability of C given D? Right there, 0.8. Are they equal? Yes. So if they are equal, then it's a yes. To answer the question here, yes, they are independent. Example 4. At a certain college, 80% of students take statistics and 36% of students take economics. Given that students take statistics, 30% of these students take economics. Part A, let S be the event that a student takes statistics, let E be the event that a student takes economics. Summarize in symbols the probabilities described above. And the symbols I'm looking for are things like in the previous examples. P of G equals 0.45, P of H equals 0.15. Okay, so we're told that 80% of students take statistics. So the probability of getting someone who takes statistics, and S stands for statistics, is 80%. Now, anytime we're going to be doing any computation, we need to convert the percent back to decimals. So 80% as a decimal, so just move the decimal 2 to the left, that's 0.80. 36% of students take economics. Okay, E stands for economics, so we're saying that the probability of getting someone who takes economics is 36%. Okay, as a decimal, move decimal 2 to the left, 0.36. And then we have a last probability, which is 30%. As a decimal, that's going to be 0.30. Now, what is this last probability? Given that a student takes statistics, 30% of these students take economics. Okay, I see the word given. That automatically tells me that this is going to be a conditional probability, which means it's going to be something given something. Now the question is it S given E or is it E given S? Okay, remember that in the symbol, the second part is the given. So in this sentence, what's the given? Given statistics. Okay, so statistics is the given part. That goes second, which means the E goes first. So be careful with the order there. So S is second because it's the given part. And in my sentence here, it says given statistics. So statistics is the given part. It goes in the second slot. Now, once you have these written out, this becomes just like the previous two examples where we're going to use those three formulas. So let me write down those three formulas. Okay, so the first one involves the OR. Okay, so I'm going to write them using S and E. Okay, so I'm going to replace A with S and B with E. So the first one is the addition rule, which is S or E equals P of S plus P of E minus the and, S and E. Okay, second formula is the multiplication rule. So that has to do with the and And then the order here is going to be P of S. So it starts the same. And then I just have to remember that it alternates. So it's going to be E given S. Okay, alternates S, E, S. And then the third one is the same as the second one, except I'm going to swap that S and E, the two letters. So this will say E and S equals, this will now say E, and then it alternates also, so E, S given E. Okay, so those are my three formulas. And then the rest of these questions, I should be able to answer using one of those formulas. Part B, find a probability that a randomly selected student does not take economics. So I lied. This one does not use one of those. So we're looking at not economics, so not E, okay, which is the same thing as, remember, not is complement. And then the complement rule says that probability of a complement is just 1 minus the probability of regular. So this is just going to be 1 minus the probability of E. What's the probability of E? 0.36. So 1 minus 0.36. 0.64. To find the probability of a complement, just do 1 minus the probability of the regular event. Part C, find a probability that a randomly selected student takes statistics and takes economics. Keyword I see there's and, so I'm looking for probability of statistics and economics, which is going to be S and E. Okay, which equation am I going to use? So which equation has S and E in them? I see it right there in equation 1, but can I use equation 1? So in order to use the equation, I have to know everything else. I'm looking for S and E. I would need P of S, P of E, and P of S or E. I have P of S, it's 0.8. I have P of E, it's 0.36. Do I have S or E? I don't, which means I can't use equation 1. What about equation 2? S and E is right here, so I need to know the other two. P of S, I do know. E given S, I actually do know, 0.30. So I do know everything I need for using equation 2. So let's use equation 2. So if I recopy that, that's S times P of E given S. All right, go through and plug in the numbers. Left side, S and E, that's actually what I'm looking for, so I actually don't need to do anything there. Right side, P of S. P of S, 0.80. So that entire thing is 0.80 times E given S. Probability of E given S, that whole thing is going to be 0.30. And then let me actually do this. That's what I'm looking for. Let me call that X. Your goal is to get the X by itself. It's already by itself on the left side, which means all I need to do is the right side. 0.80 times 0.30. 0.24. And what I just found was probability of S and E. So probability of S and E (0.24). Part D, find a probability that a randomly selected person takes statistics or takes economics. Okay, keyword there is or. In symbols, I'm looking for probability of statistics, which is S, or probability of economics, which is E. Okay, which equation am I using? So which one has S or E? There's only one that has S or E, which is the first one right there. So I have to use this first one, so let's recopy this. S or E equals probability of S plus probability of E minus the and, which is S and E. Okay, go through, plug in stuff. S or E, that's actually what I'm looking for. So let me call that X. There's an equals. Probability of S, it's right there, 0.80. There's a plus. Probability of E, 0.36, minus probability of S and E. We actually just found that. S and E is 0.24. Get the X by itself. X is already by itself, so we're good. And all I need to do is the right side, so 0.80 plus 0.36 minus 0.24. 0.92. Okay, and so what I just found was the OR. So probability of S or E is 0.92. Part E, find a probability that a randomly selected student takes statistics given that the student takes economics. All right, so I see the word given. That means that this is going to be a conditional probability. So it's going to be something given something. And remember, the second slot is the given part. So are we looking for S given E or E given S? So given economics. So economics is the given part. So that goes right here, which means the S goes here. So we're looking for probability of S given E. Looking at our equations, which one has S given E in that order? Because for conditional probability, the order matters. So S given E. S given E, third equation, right there. Okay, so let me recopy this third equation. Probability of E and S equals probability of E times the probability of S given E. Go through, plug in numbers. Left side, E and S. E and S, do we know E and S? Yes, remember, for ands, the order does not matter. So E and S is the same thing as S and E. It's 0.24. So this entire thing on the left side is 0.24. There's the equals there. Probability of E. Probability of E, 0.36. There's a times there. S given E, that's actually what I'm looking for. So I'm going to call that entire thing X. And then our job is to get the X by itself. Right now it's being multiplied by the 0.36. To get rid of that multiplication, you do the opposite, which is divide. Divide by 0.36. Left side, 0.24 divided by 0.36. Round to 3 decimal places. This is 0.667. Right in red. On the right side, 0.36 divided by 0.36 will cancel out, leaving just X. And that's our answer. So we just found probability of S given E is 0.667. F. Determine if the events taking statistics, taking economics are independent. So whenever I'm asking about independent or mutually exclusive, I want you to check one of the equations on the front page. So which one are we looking at? We're talking about independent. Independent would be this one. So probability of A equals probability of A given B. So probability of A equals probability of A given B. So that's what we're checking. In this problem, we're talking about S and E. So let me replace the A with S and the B with E. And then all we need to do is check the left side, check the right side, and see if they're equal. Left side, probability of S. What is probability of S? Just regular S is 0.80. On the right side, S given E, we actually just found it, 0.667. Are they equal? They're not equal. Okay, so to answer the question, they're not independent. Part G, determine if the events taken statistics, taken economics are mutually exclusive. Okay, I'm asking about mutually exclusive. That means I want you to check one of the equations on the front page. This one's asking about mutually exclusive. The equation to check for mutually exclusive is this one. Probably A and B equals 0. And then in this question, we're talking about, instead of A's and B's, we're talking about S's and E's. So probably S and E equals 0. Check left, check right, and check if they're equal. Left side, S and E. We found that somewhere. What is probability of S and E? S and E, right there, S and E is 0.24. That's left side. Right side, there's nothing to do because it's just 0. So right side 0. Are they equal? Obviously not. They're not equal, which means to answer the question, are they mutually exclusive? They are not. So not mutually exclusive. Example 5. At a school, 83% of all students carry a backpack, 64% of all students bring their lunch, 89% of all students carry a backpack or bring their lunch or both. Part A, let B be the event that a student carries a backpack. Let L be the event that a student brings their lunch. Summarize in symbols the probabilities described above. Okay, so the first one I need to translate is the 83%. 83% as a decimal, so move the decimal point 2 to the left. That's 0.83, so 0.83. And that was the probability that a student carries a backpack. And backpack was B here. Next one, 64% of all students bring their lunch. Lunch was L. Probability of getting someone who brings their lunch is 64%. As a decimal, move the decimal point 2 to the left, 0.64. Then the last probability is 89%. As a decimal would be 0.89. And what is that? So 89% of all students carry a backpack or bring their lunch or both. Okay, so keyword is or. So or both is actually included in an or. So 0.89 is the probability of backpack or lunch. So B or L. Okay, so once I have this, I'm going to use those 3 equations that we've been talking about, and I'm going to rewrite them using B's and L's. Okay, so the addition rule with B's and L's is going to say probability of B or L equals probability of B plus probability of L, and then minus the probability of B and L. Second equation I need is the multiplication rule. Multiplication rule is the one for and, so B and L equals, it's going to start the same, so probability of B times probability of, and make sure you get this order correct. The way I remember it is it alternates, so B, L given B. And then the third one is the same multiplication rule, except you swap the B's and L's. So this one would say probability of L and B equals probability of, this will now say L times the probability of B given L. Okay, make sure it alternates, so L, B, L. Part B, find a probability that a randomly selected student does not bring their lunch. So I'm looking for not lunch, so not L, which is really just, remember, not is complement. I'm looking for L complement. To find L complement, you're just going to do 1 minus the regular event. So 1 minus the probability of L. So 1 minus, what's the probability of L? 0.64. So 1 minus 0.64. 0.36. So if you know that the probability of someone bringing their lunch is 0.64, to get the probability that they don't bring their lunch, just do 1 minus it, 0.36. Part C, find a probability that a randomly selected student carries a backpack and brings their lunch. Keyword there's and. So I'm looking for probability of backpack and lunch. Backpack and lunch. Which equation am I going to use? So I'm looking for equations that have B and L in them. I see one right there. I see one right there. And then for ands, the order does not matter. So that counts too. Which one's going to work? So in order to use an equation, we have to know everything else. B and L is right here. In order to use this equation, I need to know the other three things. So B, L, and then B or L. Do I know B or L? Yes. Do I know probability of B? Yes. Do I know probability of L? Yes. Okay, so equation 1 works here. So let me recopy that. And let's go through and plug in numbers. Probability of B or L, we know, is 0.89. So that entire thing is 0.89. There's an equals here. Probability of B, we also know that's 0.83. There's a plus. Probability of L, 0.64. Minus probability of B and L. That's actually what I'm looking for. So let me call that X. Our job is to get the X by itself. Okay, so right now I need to get rid of these two things. Let me clean up left, clean up right before we move on. Left side, 0.89. Right side, I can combine those. So 0.83 plus 0.64 is 1.47. And then I have this minus X. To get the X by itself, I need to get rid of this 1.47. Right now, it's being added to the minus X. So to undo an addition, you're going to do the opposite, which is subtract. So subtract 1.47 from both sides. And I'm going to spill over to the next one. So minus 1.47 minus 1.47. Left side, 0.89 minus 1.47. So 0.89 minus 1.47. That's negative 0.58. Equals, right side, 1.47 minus 1.47 will cancel each other out, and you're left with just negative X. I'm looking for regular X, not minus X. But if I know that negative 0.58 is negative X, then I know regular X should be 0.58 without the negative sign. Okay, so what did I just find? I just found the x, which is the and. So I just found p of p of b and l is 0.58. Okay, so that was part C. Part D, find the probability that a randomly selected student carries a backpack given that the student brings their lunch. Okay, so given. So this is going to be a conditional probability. So I'm looking for something given something. Backpack given lunch. So this is the given part is the second slot. So given lunch, so that goes there, backpack goes there. So backpack given lunch. I'm looking for probability B given L in that order. So which one has B given L? Which equation has B given L in that order? That's right there. Equation 3. So let me recopy that. It's a probability of L and B equals probability of L times probability of B given L. Go through, plug in numbers. Left side, probability of L and B. Do we know that? So remember I said the order does not matter. So L and B is the same thing as B and L. And B and L, we actually know, is 0.58. Equals probability of L. I should know that. That's 0.64. Times B given L. That's actually what I'm looking for here. Let me call that X. Our job is to get the X by itself. So we just have to get rid of this 0.64. This 0.64 is currently multiplying. To undo a multiply, you divide the opposite. So you divide by 0.64. Left side, 0.58 divided by 0.64. Rounded to 3 decimal places. This is 0.906. On the right side, 0.64 divided by 0.64 will cancel out, leaving just an X. And that's our answer. So what is this answer? This answer was the probability of B given L. So probability of B given L is 0.906. Part E, find a probability that a randomly selected student brings their lunch, given that the student brings a backpack. Keyword there is the word given. So this is a conditional probability, so we're looking for something given something. Lunch given backpack. So that would be L given backpack. So looking at my 3 equations, which one has L given backpack in that order? Because conditional probability, the order does matter. So L given backpack in that order. L given backpack. I see it right there. So equation 2. Okay, so let me recopy equation 2. That's probability of B and L equals probability of B times probability of L given B. Go through, plug in numbers. Probability of B and L. I should know that somewhere. So B and L, we found it somewhere. Right there, B and L, 0.58. Equals probability of B, I should also know that. Right there, 0.83. Times probability of L given B. That's actually what I'm looking for, so let me call that X. And then our job is to get the X by itself. Right now, it's being multiplied by 0.83. To undo a multiplication, you're going to do the opposite, which is divide by 0.83. 0.58 divided by 0.83. 0.699. That's the left side. Right side, 0.83 divided by 0.83 will cancel out, leaving just an x, which is our answer. So what is this answer? It was probability of L given B. 0.699. F. Determine if the events carrying a backpack and bringing a lunch are mutually exclusive. So anytime I'm talking about mutually exclusive or independent, I'm asking you to check one of the equations on the front page. Okay, so which one are we checking? This one or this one? We're asking about mutually exclusive, which would be this one. So probability of A and B equals 0. And then because for this problem we're talking about B's and L's, right? B's and L's, let me replace the A with B and the B with L. So this will say probability of B and L equals 0. Check left, check right, and then check if they're equal. Left side probability of B and L, that we should have somewhere already. Right there, B and L, 0.58. B and L, 0.58. Right side, there's nothing to do, it's just 0. Are they equal? No, they're not. So they're not equal. That means, to answer the question, this is not mutually exclusive. G, determine if the events carrying a backpack and bringing lunch are independent. So independent, we're checking the other equation. Independent, P of A equals P of A given B. Okay, so this question we're talking about backpacks and lunches, so that's B's and L's. I'm going to replace the A's with B's, and then the B with L. Right. Check left, check right, and then check if they're equal. Probability of B. B would be 0.83. On the right side, B given L. B given L, that's not it. That's in the wrong order. That's not what I want. B given L, right there, 0.906. That was from part D. Are they equal? Nope, they're not equal. So our conclusion would be that they are not. This one's talking about independent, so they're not independent. All right, have a great day, and I will see you in the next one.